Hello, welcome again. We are solving GATE 2022 Mechanical Engineering Paper 2. Question number 32 is an electric car manufacturer underestimates the January sale of car by 20 units while the actual sale was 120 units. If the manufacturer uses exponential smoothing method with a smoothing constant of alpha equal to zero point 0.2, then the sales forecast for the month of February of the same year is dash units in integer. So actual sales in January is 120 units and the error is 20. So the forecast is 120 minus 20, so that is 100 units. Okay, so by using exponential smoothing method, we have forecast for the next period is equal to forecast for the current period plus alpha into error. Okay, so uh, so forecast for the current period is 100 and alpha is zero point 0.2, so and dn minus fn is 20, so answer is 104 units. Okay, next, the demand of a certain part is 1000 parts per year and its cost is rupees 1000 per part. The orders are placed based on the economic order quantity EOQ. The cost of ordering is rupees 100 per order and lead time for receiving the order is 5 days. If the holding cost is rupees 20 per part per year, the inventory level of placing the order is dash part, round up to nearest integer. So demand is 1000 parts per year and or 1000 by 365 parts per day, and so the consumption rate, okay, because the consumption per day, so that is 1000 by 365 and lead time is 5 days. So in 5 days, if we multiply it by 5, this much of inventory will be consumed. So we have to place order according when the inventory level is left as this quantity or as 14. So answer is 14. Next, consider a consider 1 kilogram of an ideal gas at 1 bar and 300 Kelvin contained in a rigid and perfectly insulated container. The specific heat of the gas at constant volume CV is equal to 750 joules per kilogram per degree Kelvin. A stirrer performs 225 kilojoule of work on gas. Assume that the container does not participate in the thermodynamic interaction. The final pressure of the gas will be dash bar. So work is done on the gas, so it is negative, and work done is 225 kilojoules. Okay, and heat supplied is as no heat is supplied, so heat supplied is 0. So using first law of thermodynamics, we have Q is equal to del U plus W, and del U comes out as 225 times by 3. So this is your CV delta T. So delta T is your 225 times by 3 divided by CV is your 750. So delta T is your 300. So T2 minus T1 is your 300. So T1 initial temperature is 300 degree Kelvin. So T2 is your 600 Kelvin. Okay. So final temperature is 600 Kelvin, because and using the state equation between 1 and 2, we have P1 V1 by T1 is equal to P2 V2 by T2. So as the vessel is rigid and perfectly insulated, so there will be no change in volume. So V1 is equal to V2. So P1 by T1 is equal to P2 by T2. So now we have all these things, and P2 is just 2 bar. Its answer is 2 bar. Next, Wien's law is stated as follows: lambda m T is equal to C, where C is 2898 micrometer Kelvin, where lambda m is wavelength at which the emissive power of the black body is maximum for a given temperature T. The spectral hemispherical emissivity epsilon lambda of a surface is shown in the figure below. 1 angstrom is equal to 10 to minus 10 meter. The temperature at which the total hemispherical emissivity will be highest is dash Kelvin, round up to the nearest integer. So this is the temperature, this is the emissivity, and the maximum emissivity is at 6000 angstrom wavelength. Okay. And according to beam displacement, the lambda m into T is equal to constant, and lambda m is 6000 angstrom, and C is 2898.10 to minus 6, that is given, okay, micrometer Kelvin. Okay, so from this we can calculate T is 4830 Kelvin. So the maximum temperature, the temperature at which the emissivity is maximum is 4830 Kelvin.